Welcome to aminacademy.com. In linear algebra, let us discuss about row echelon matrices. In linear algebra, a matrix is in echelon form if it has the shape resulting from a Gaussian elimination. A matrix being in row echelon form means that Gaussian elimination has operated on the rows and columns. Echelon form means that column echelon form means that Gaussian elimination has operated on the columns. In other words, a matrix is in column echelon form if its transpose is in the row echelon form. That means from row echelon form we can get a column echelon form by using transpose of the matrix. Therefore, only row echelon forms are considered in the remainder of this article. The similar properties of column echelon form are easily deduced by transposing all the matrices. Specifically, a matrix is in row echelon form is all rows consist of only zeros are at the bottom. The leading entry, that is the leftmost non-zero entry of every non-zero row, is to the right of the leading entry of every row above. Now let us do pointwise. All zero row are the bottom of the matrix. The leading entry of each non-zero after the first occurs to the right of the leading entry of the previous row. The leading entry is in any non-zero row is 1. All entries in the column above and below the leading one are 0. Another common definition of echelon form only requires 0 below the leading ones, while the above definition also requires them above the leading ones. Here, look at this. This is an example for row echelon form. Look at this. Here, this in diagonals, below the diagonal, these are zeros, and here also 0. This is called a row echelon form matrix. Now let us do an example to understand this concept. Reduce the following matrix in row echelon form by using row reduced method. Here, look at this matrix. This matrix is augmented matrix given 3 rows, 4 columns. Here, by replacing some rows to get a required zeros in below the diagonals. Look at this here. Here, look at this first row, 1, 2, minus 3, 0, and look at the second row, 2, 4, minus 2, 1. Minus 2 and 2. Here this first, let it be, this is a pivot element, 1. So you have to get it below the pivot element, these are zeros. That is here, the zeros. For that, if you multiply row with minus 2 and add with row 2, what happened? Look at here. Replace R2 by minus 2R1 plus R2. That means I multiply with the first row with minus 2 and add up with the second row, we'll get, and another one, row 3 operation by minus 3R1 plus R3. Look at this one. If you multiply with this row with minus 3 and add up with this third row, we'll get 0 here also. So look at these operations. First we write the given matrix as it is, and the second row operation is minus 2R1 plus R2. Third row operation is minus 3R1 plus R3. Look at here, this first row we are not doing anything, so we have to write as it is. The second row becomes 0, 0, 4 and 2. For example, here the second row is minus 2. R1 is minus 2 and minus 3 is 6, and minus 2 addition of the second row, this 2 becomes 4. That means minus 3 into minus 2 equal 4, and this 2 also comes like. Then third operation, that is third row operation, is minus 3r1 plus r3. Look at here, 3r1 minus 3r1 is minus 3 into 1 is minus 3 plus 3 is 0. Like that, other terms will come like. Here we got that here these are zeros. Below the pivot, these are zeros. Further, we have to consider this 4, that is element A, 2, 3 is a 4 here. We have to consider as a pivot. For that, pivot means we have to get it that, look at here, replace R3, that is we need the 0 here, R3 by minus 5R2, minus 5 into 4 is 20, minus 20 plus 4 into 5 is plus 20, add up, that becomes 0. That is, this element becomes 0. For that, look at this operation. Here, 1, 2, these are the given. Now, after operating 2 rows, we have get this one. From that, operating third row with minus 5R2 plus 4R1, it becomes, look at here, minus 5R2. Minus 5R2 is minus 5 into 4 is 20 and 4 into 5 is 20. That is minus 20 plus 20 is 0. That becomes, look at this, this becomes other things also zeros. So this is row echelon form, we got it. Look at here, so far we have done the definition of a row echelon form of matrices, and as well we got an example. Next one, we did one example, reduce the following matrix in row echelon form by using reducing method, row reducing method. Here this is a given matrix, we have to replace some rows to get a zeros under the pivot element. Here pivot element is here. Next, third row operation to get a that means we get this one. Look at here, this is a 4 is a new pivot element. From below that one we have to get it this as 0. We got it like we have done. Please subscribe our YouTube channel.